Hello students, welcome to the lecture series of the M.Sc. part 1st physics, and this is lecture number 4 of the mathematical methods in physics. Okay, in the last lecture we have talked about the complex functions or the CR equation conditions that we are already talked in the last lecture. Okay, so today we are going to discuss one important concept of this subject, that is analytical or analytic functions. Okay, or the analytical functions. Okay, so for this analytic functions there is some property for these functions. If functions is analytical, then this some properties that follow by these functions, then we can call it is analytical. Okay, so first property is what? Single value functions. In the last previous sessions what we discussed, functions that is in a W plane. So this function has two possibilities. It is maybe it is a single value functions or it is a multi-value functions. Okay, so if we put the z in the functions and we got the single value, then it is called the single value functions. Okay, and second one, that is if this function is continuous and unique derivative at each point of the domains. Okay, this is a important property if the function is analytical. Here point is each point means whatever we consider domains. Suppose this is the domains, and here is one point that is z known, and others points that present on the neighbor of this z. So this point is at this point also this function is a unique derivative. Okay, so in the domains at each point this function has a unique, or this derivative is it is differentiable, these functions, or it is continuous and differentiable at the all point, what are the point present in this domain. Okay, so let's also there is one definitions. So definitions for this analytical functions. So if complex functions, that is f of z is equal to w, is said to be analytic if at point z is equal to z naught, if f prime z is equal to, or the dw dz, this is functions, that is what f of z is equal to w is equal to limit del z tends to 0. Okay, this is point del z. I will explain this. Okay, so f of z plus del z minus f of z divided by del z is exist and unique at z is equal to z naught, or and also neighborhood of, or a neighborhood of this point, that is of z naught. Okay, so this is point what we consider here. Okay, this point, that is z, and here numbers of point is present, suppose, and this point z naught if we consider. So at every points in these domains this functions is differentiable and continuous. Okay, so then we can call these functions is a analytic. Okay, so this is about the definition of the analytical functions. But if you want to check this function is analytic or not, so there is another way to check this function is analytic or not. So in the last sessions we discussed about the CR equations or the Cauchy-Riemann equations, and also it is pronounced as the Cauchy-Riemann equations. So there are by these equations we know that there are some conditions. If these conditions exist, so we can say this function is analytical. Okay, so let's Cauchy and equations. Okay, so by the Cauchy or the Cauchy-Riemann equations, we know the dou u or dou u by dou x is equal to dou v by dou y. This is first conditions, and second one, that is dou u by dou y is equal to minus dou v by dou x. Okay, so these are the two conditions. If function function satisfy these two conditions, then we can call the function is analytical. Okay, so this is way to check the function is analytical or not analytic. Okay, so this we can rewrite as u, this is a superscript. So u x I read as a ux is equal to this it is v y, okay, and this u y to minus vx. Okay. So we can write in this form also. Okay, so this is two conditions of this. If function is satisfied, then in called it is analytical functions. Okay, so let's consider one example, then you can understand. So example, functions f is equal to f of z is equal to z mod square. Okay, this is functions. It is we want to check it is analytical or not. Okay, by this CR equation. So first we know this z is equal to, in the complex variable, that is x plus iota into y. Okay, so if we take if we simplify, then what we get, mod z whole square is equal to x square plus y square. Okay, these things. Okay, so we know this f of z is equal to omega also, and this we can write u x is a function of the x and y plus iota into v x into y. Okay, so this is equal to what, x square plus y square. Okay, from this z mod square is equal to what, x square plus y square. So this is real function, x square plus y square, this is a real. Okay, so u, if we compare this equations or this function f of z with this equation, so we can write u j x and y is equal to x square plus y square, and this imaginary terms, that is equal to 0. Okay, so this v x and y is equal to 0, right? So sorry, here is not iota. Okay, so this is if we differentiate with respect to the x of this for this u, so we can dou u by dou x. So also you can write this is u of x, okay, from this forms, okay. So dou u by dou x is equal to u of x, or the u super subscript x, and if we take the derivative of this u with respect to the x, so here we get the 2x. Okay. Similarly for y, okay, so it is dou u by dou y is equal to u of y, and this is equal to here 2y. Okay, so this is about the only u, and if we differentiate v with respect to x and y, so we get it is 0. Okay. So dou v by dou x is equal to 0, or vx, okay, v of x like this, and dou v by dou y, this is equal also 0. Okay, so we can write. Right. So now the from the Cauchy or the CR equations, by CR equation, okay, so if you compare this two, that is ux is equal to v of y, so this is equal to what, ux is equal to what, 2 into x, and v of y, this is equal to 0. Okay, this is first conditions of the CR equations, and the second one, that is second condition is this one. Okay, so that is u of y minus v of x. Okay, so u of y, this is equal to 2y, and this is minus 0. So this is two conditions that by these functions, or we consider f of z is equal to z mod square, it not satisfy these two conditions, so we can call this function is not analytical. Okay, but at the point, or at the origin, if we consider here x is equal to 0 and y is equal to 0, so this in the both side here is also 0, and this also means left hand side and the right hand side, we can both terms is equals. Okay, here also if we consider y is equal to 0 and x is equal to 0, so this x is equal to 0 and y is equal to 0, this is nothing but the origin. Okay, so at the origin this functions is differentiable. Okay, but other neighborhood of the origin that are not, this function is not differentiable. Okay, so condition is what, the second property we already discussed. At the point here x is equal to 0 and x is equal to 0 and y is equal to 0. Okay, so at this origins this functions is differentiable, but other points, whatever the other point is present, here is not differentiable. Okay, that is a things means by the second property what we are consider in the. Okay, so I hope you got this point. Let's check another one example, you can understand better. So next example, I will take example, second example, that is f of z is equal to 1 by z. Okay, this is the functions. So first we rewrite these functions in the term of the u and v. Okay, so we know that this z is equal to x plus iota into v, but we can't write in the term of the u and v. So for that I just multiply with the complex conjugate of this complex number. Okay, denominator and the numerator. So z bar, this is the complex conjugate of this complex numbers, and z into z bar. Okay, so now if I write z bar is equal to what? X plus x minus iota into y divided by z by, this is what, x plus iota into y into x minus iota into y. This relation we already derived, that is x square minus y square. Okay, so okay, if let's say I am again prove this x square, okay, minus iota into xy plus iota into y x minus I into I, that is a square, and I square is equal to what? Plus. Okay, so I write here I square first, and the y into y, that is a y square. Okay, so now this two terms that cancel, and x minus iota into y divided by x square, and here I square, that is minus 1, and this minus, so if multiplies, so it will here must be plus sign, that is okay, and this x minus iy divided by x square plus y square. Okay, so this is now we are having the functions. Okay, f of z is equal to x minus iota into y and divided by x square plus y square. Okay, so we can rewrite f of z in the term of the u or u plus iota into v. Okay, so from this we can write x u is equal to, or I am directly write it, x by x square plus y square plus iota into y by x square plus y square. Okay, so this is in the term of this u plus iota into v. Okay, so u is what? X by x square plus y square, and v, that is y by x square plus y square. Okay, this u and v is what? Variable in the w planes. Okay, that we already discussed. So now by CR equation, what is a condition for the CR equation? U du by dx is equal to dv by dy, and du by dy is equal to minus dv by dy. Okay, these are the two conditions. So if we differentiate this u with respect to the x first, and then y, like that. So let's try. If du by dx, so du by dx. Okay, so here is a x by x square plus y square. So I apply here this rule, that is f of dash, this is equal to what? F dash g minus, okay, right here, f by g. If we find the different derivative of this function, so it is f dash g minus g dash f divided by g square. Okay, so I apply this rule different derivative rules here, so okay, for this u. Okay, so this is with respect to the x, so I am directly write here the answer, that is y square minus x square divided by x square plus y square whole square. Okay, this is for the du by dx. And if dy by dv by the dy, this is a similar things. Okay, here is only x and here is what y. Okay, so if we differentiate the same thing, we can find, so also dv by dy. Okay, same from same rules I apply here, so that is also y square minus x square divided by x square plus y square bracket square. Okay, so now first conditions, these first conditions that already we pro here, or it is exists. Okay, now next condition, we try for the next conditions. Okay. So next one is what y u with respect to the dou u by dou y is equal to what, so if I it is minus 2xy divided by x square plus y square whole square, right? This is for the du by dy, and the dv by dy is also we get the same thing, so it is dv by dy is equal to so it is minus 2xy, I think here. Okay, similarly things, if we differentiate dv by dou v by dou y, so these things, so here also we get the same thing, so this is equal, I am directly right here, that is equal minus dou v by dou, I think here mistakes. Okay, sorry, here is a mistake one, that is dou v by dou x. Okay, that's confusing. Okay, this is the conditions. So minus dou v by dou x, this is same thing to for second case is also satisfied by these functions, and first one is also satisfied. So we can write dou u by dou x is equal to dou v by dou y is equal, okay, that is equal to y square minus x square by x square plus y square whole square. Okay, so if this two condition is satisfied, then we call this functions f of z is equal to 1 by z is analytic at point z is equal to z naught. Okay, and also neighborhood. So this function is analytical because this all differentiability or this conditions here equations that is satisfied by these functions. Okay, so this is analytical. In the last lecture also we call this condition is sufficient condition but not necessary. Okay, so necessary condition is what, this u of x, v of x, u of y and v of y, like this is, these are the necessary conditions. Okay, okay, so this is about the CR or the CR equation or the Cauchy-Riemann equation in the Cartesian form. Okay, so now we are going to discuss polar form of the complex the polar form of this okay, so polar form of this Cauchy-Riemann equations. Okay, just 5 minutes we complete this and then stop. Polar form of Okay, polar form of the Cauchy-Riemann equation. So we know the z is equal to, in the term of the polar form, that is r e raised to I theta. Okay, and the r is equal to, I am not going to detail these things. R is equal to, we know, the under root x square plus y square, and the x is equal to what? R cos theta, and y is equal to r sin theta. Okay, these are the important things, these relations. And also f of z is equal to what? U of r n theta. This is in the this function in the term of the polar. Okay, this r n theta, these are the variable that is in the polar systems, and u is a function of the r n theta, and this plus eta v is also the r n theta. Okay, so now if we differentiate du with respect to the r, okay, so du by dr is equal to, we can write by the chain rule, by chain rule. Okay, so we can write dou u by dou r is equal to what is dou u by dou x into dou x by dou r plus dou u by dou y into dou y by dou r. Okay. This is the first equations if we quotes, and if we differentiate these things, x is equal to r cos theta, so this is dou x by dou r. So here we can rewrite this cos theta dou u by dou x plus dou u by dou y. This y we differentiate with respect to the r. Okay, so here we get the sin theta dou u by dou y. Okay, this is equation number first. And similarly for the dou u by dou theta. Okay, so now this x we differentiate with respect to theta like that. So dou u by dou x into dou x by dou theta plus dou u by dou y into dou y by dou theta. Okay, so these things, this x we differentiate with respect to the theta. So here r cos theta, so we get the here minus minus r sin theta dou u by dou x, okay, plus dou y by dou theta. So here we get the r cos theta dou u by dou y. Okay, this is equation number second. Now similarly for the dou v, and now I am directly write this dou v by dou r. Okay, this v is what variable in the w planes, these things. Okay, so similarly if we write these things and then take this dx by dr for this v, so here we get the like this dou v by dou x into dou x by dou r plus dou v by dou y into dou y by dou r. Okay, so just dx by dr I am putting here for your understanding. So what we get, cos theta, okay, if we differentiate with respect to that r, so this thing is what cos theta, and remaining term is dou v by dou x. Okay, and the plus here is a sin theta, and remaining term is what dou v by dou y. Okay, similarly for the dou v by dou theta, this is equation number 3. Okay, and similarly I write this form, only change these things, dou u by dou x, here is only dou v by dou x like this. Okay, so here minus r sin theta dou v by dou x plus r cos theta dou v by dou y. This is equation number 4. Okay, so okay, so now by using this 4 equation 1, 2, 3 and 4, we can find this the polar form of these analytical functions. So if we consider this dou v by CR equation is what? Ux is equal to v of y and uy is equal to minus v of x. Okay. So u of x is equal to what? Du by dx, right? So and v of y is equal to what? Dv by dx, like this. Okay. So dv is equal to dr cos theta, I am right, cos theta, and this dv by dx is equal to what? These things, v of x, and that is equal to u of x. So I am right here du by dy. Okay, and minus, this minus is in this side. Okay, so plus sin theta is as it is, and dv by dy, so that is these things. Okay, so it is du by dou u by dou x. Okay, and now okay, now just multiply with the minus 1 by r. So what we get? Cos theta dou u by dou y minus sin theta dou u by dou x. Okay, here is r. Okay, so these things 1 by r, if we compare with these equations, where is it? Minus r sin theta dou u by dou x, so minus r sin theta dou u by dou x plus r cos theta dou u by dou theta. So we can write these things, okay, here. So it is minus dou u by dou theta. Okay, so dou r by, sorry, dou v by dou r. This is first conditions, dou v by dou r is equal to what? Minus 1 by r dou u by dou theta. Okay, and the next one, now no need to for this one. Okay, now using this equation number 4 and 1, we can rewrite this dou v by dou theta is equal to minus r sin theta dou v by dou x. I am directly right here. This dou v by dou x, that is nothing but what? V of x, right? So I replace this dou u by minus dou u by dou y. Okay, for this, and the plus r cos theta, that is dou v by dou y, that is equal to dou u by dou x. Okay, so now if you compare these equations like this, this is what? R cos theta dou u by dou x plus r sin theta dou u by dou y. Okay, so this is cos, if we take the common, it is r, and cos theta dou u by dou x plus sin theta dou u by dou y. Okay. So compare this equation, cos theta is equal to what? Dou u by dou x plus sin theta dou u by dou y. Okay, so we can write this r, this is what? Dou u by dou r. Okay, so just write here dou u by dou r, and this is equal to dou u by dou theta. Okay, so these are the two conditions of the CR equation in the term of the polar forms. Okay, dou v by dou theta is equal to r dou u by dou r. Okay, dou v by dou theta is equal to r into dou u by dou r, and dou v by dou r is equal to minus 1 by r dou u by dou theta. Okay, these are the CR equation in the term of the polar forms. Okay, so let's stop here. Next lecture we discuss the entire functions and the harmonic functions of this analytical, and also we are going to discuss singularity of the functions. Okay, so let's stop here.